In this video, we'll be looking at electricity. Now here we'll look at resistors in series, resistors in parallel, calculation of voltage, current, and resistance. Then we are done. Now know that electricity is the flow of current in a conductor. So if this is a conductor, and the current is starting from there, and the end of the conductor is here. So current is going to flow in that in form of electron up to the other end of the conductor, and the flow of these, that's what we call electricity. The flow of current, that was called electricity. Now what is current? Current is the flow of electrons. So don't confuse the two definitions. Current is the flow of electrons, electricity is the flow of current, and that's what you must know. So without wasting much of the time, let's go to series and parallel combination of resistors. Now we know that in series, resistors are connected direct to each other. So let me say this is a resistor, another resistor, another resistor. So they are connected like that. If this is 2 ohms, and this is 3 ohms, and this is 5 ohms, hence these will be added direct, and we say the total resistance will be equal to resistance 1 plus resistance 2 plus resistance 3, to give us 2 plus 3 plus 5, which is 10 ohms. That's how we find the resistance in series. You add it direct. In the parallel, resistors are connected also in a straight line, but they are parallel to each other. What do we mean by they are parallel to each other? So one resistor can be there, another one can be there, another one can be there. So they are connected like that. All right. So if this is a circuit, you'll be able to know that, to see that this is a circuit. So we know that in parallel, if this is 2 and this is 3 and this is 5, we know that total resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3, and 1 over 2 plus 1 over 3 plus 1 over 5. So from there you need to find the common denominator where all can go, and the simplest one is 30. So 2 into 30, that's 15, plus 3 into 30, that is 10, and 5 into 30, that is 6. So when you add 15 plus 10 plus 6, that is 31 over 30. Remember here we have 1 over total. It's supposed to be 1 there. So to find RT, we swap. This one comes up, then this one comes down. So you are saying that is 30 over 31. When you divide 30 by 31, you are having 0.97 ohms. So you can see that resistors in series is higher than the total resistance in parallel, because in parallel we are taking into consideration a lot of things, because in parallel we know that voltage is the same but current is not the same, while in series voltage is not the same but current is the same. Let's look at this example. How can you calculate the total resistance in this? I know that this part is in series, but these two are in parallel. So since this one is in series, we first have to deal with this guy, which is the other side. And we know that also when two resistors or three are connected in series, total resistance in parallel the resistance in parallel can also be found by R1 times R2 over R1 plus R2. So we know that here we're going to get 3 times 4 over 3 plus 4. So we're having 12 over 7. Now what is 12 over 7? We are having, so to the two decimal places, we're having 1.71 ohms. So now we need to add this one, which is in series, because they are now in series. You are now having something like this, 2 connected to 1.7. So now this can be added direct, and the total is 3.71 ohms as your total resistance. So just need to play with that. How do you calculate voltage? We know that Ohm's law, which states that the current flowing through a conductor is direct proportion to the voltage. So current flowing through the conductor, I'm not going to write it, just have to write it the way I'm going to say it. The current flowing, so the current which is flowing through the conductor is direct proportion to the voltage between the two ends of the conductor, provided that the temperature, which is resistance, remains constant. So therefore this equation is written as voltage is equal to current times resistance, where current and voltage, they are direct proportion to each other, but voltage and resistance, they are indirect proportion to each other. And this is what we call Ohm's law. So I'm going to repeat. Ohm's law states that the current flowing through the conductor is direct proportion to the voltage between the two ends of the conductor, provided the temperature remains constant. The temperature we're talking about is resistance. Now we know that the equation IR has got voltage, which is measured in volts, has got current, which is measured in amperes, and has got resistance, which is measured in ohms. So you must know that. Calculate the voltage. Calculate V from the following. If I give you current to be 2 amperes, and I give you resistance to be 6 ohms, we know that V is equal to current times resistance. So we're going to have 2 times 6, which is going to give us 12 volts. So we've got a diagram there. The question says calculate the total current in the circuit. Now we know that we are going to use the equation voltage is equal to current times resistance. Hence current is equal to voltage over resistance. What do we have? Voltage we have is a 3 volts. Do we have resistance? No. Let's find the total resistance. That is 2 plus 6 to give us 8 ohms. So current is equal to 3 over 8. When we divide 3 by 8, to give you 0.375 amperes. Question 2. Calculate the voltage in A, the 2 ohm resistor, B, the 6 ohm resistor.
It was possible. But
Therefore, how can we calculate the voltage in 2 ohm resistor and 6 ohm resistor? Now know that in series, current is the same. And we found our current to be 0.375 amperes. That means here there is 0.375. Even here there is 0.375 amperes. So in series, current is the same. Now how can you find voltage? We know that voltage is equal to current times resistance. So for A, we are saying current is 0.375 times 2 ohms, and you are having 0.75 volts. But B, we know that voltage is equal to current times resistance. Current is 0.375 and resistance is 6. So when you multiply 0.375 times 6, you're having 2.25 volts. Now, when you add 2.25 and 0.75, it should give you the total 3. So plus 0.75, that should give you, actually it's giving, when I add this one to this, giving me 3 volts. That means all your answers are correct. So even when I give it in parallel, apply the same principle. So thank you so much for watching. Don't forget to subscribe and pay this tutor Zambian help a boy. I hope you share and make sure you comment when you understand or when you don't understand. And in case you want a topic where I would like to make a video with you, you can just comment and I'll be able to help you. Peace.